This video explains you more about the pathways to digital manufacturing that are developed by the Connected Factories Coordination Action. Two videos were released before about these pathways. The first focuses on the digitalization within the factory floor. That pathway is called the Autonomous Smart Factories pathway. You can find a link to that video in the description below or on the Connected Factories web pages. The second video focuses on a pathway that is called hyper-connected factories, where the main perspective is the digitalization in value networks, meaning that we stepped outside the boundaries of a factory and looked into the connection to other factories that are part of a manufacturing ecosystem or value network. This video is about the collaborative product-service pathway, which focuses on the concept of servitization from the perspective of a manufacturing company. The pathway aims at capturing how the manufacturing company is progressively embracing a service-oriented business model without dropping the product-oriented business model. The need to progress towards service innovation around the product has already been well understood by big companies. Some of the companies generate already around 50% of their revenues by the post-sales services associated to training, maintenance, upgrades, etc. While big companies have already understood the product-service concept, SMEs have more difficulties to understand the association with services, in particular if they produce high-tech components. The danger for them is that they abandon their product after sales, while also missing the opportunity to create jobs in service and post-production jobs. This would also enable the shift of job profiles that are more associated to service delivery. A pathway is composed of different levels of digitalization that are associated to a number of milestones. These milestones indicate practices of digitalization that, while evolving to the right-hand side of the pathways, become more advanced. Level 1 is the situation where the full focus of the manufacturing company is on the product, and where it does not or hardly address the services associated to that product. Level 2 of the pathway implies that the manufacturing company has understood the opportunity for growth and job creation offered by associating services to their product in a structured way. This understanding is linked to the fact that products are seen within their full life cycle and the complex interaction across different stages of their life cycle. From the technological point of view, this requires that the product can be tracked and traced remotely. A product lifecycle system should be able to manage this information and also provide insight into the evolution of the product, even to the stage of retrofitting, reuse and recycling. The fact that a manufacturer does not lose the connection or even the control of the product along its lifecycle is a precondition for the structured development of services that are closely associated and integrated with the product. In Level 3, design and engineering processes of the product are opened to the requirements and needs from the different stakeholders along the whole life cycle of the product: suppliers, business partners, customers. So Level 3 is about creating a collaborative environment beyond the boundaries of the manufacturing company. This involvement of users is different when the users are consumers or professional users. Level 3 is a preparation phase in order to be able to integrate innovative services in the product, also called design for service, in Level 4. It also assures that the design of new products are not taking place in silos anymore. It assures also that products, such as machine tools, are engineered more specifically according to the needs of the use of the machine tool. Level 4 is the further evolution of the process started in Level 3, where innovative services are designed in partnership with the different stakeholders and delivered, sometimes in cooperation with specialized service companies. For example, predictive maintenance services are offered in cooperation with specialized predictive maintenance service companies. This requires the sharing of data among the different parties and the conclusion of associated B2B agreements. Level 5 is when the company has transformed its business and product service processes at all levels, embracing digital technologies like IoT and data analytics, integrating this with the hardware and manufacturing aspects like materials engineering, covering organizational aspects where, for instance, salespeople are both addressing the technical aspects as well as the business service aspects. In the collaborative product service pathway, the link between the business objectives, shown in the bottom row of boxes, and the technological and digital aspects that enable to reach these business objectives is less obvious than in the two previously presented pathways, autonomous smart factories and hyper-connected factories. Let's look into some cases and examples from projects. The project ICP for Life proposes an integrated collaborative platform that addresses the need for a neutral, easy-to-interface system, featuring a more efficient collaboration strategy and an effective knowledge-sharing environment. In one of the project use cases, a manufacturing company uses laser cutting machines in their production facilities. The supplier of the laser cutting machines and the associated services obtains information about required features and associated services via the ICP for Life customizer component. The customizer component offers web-based applications for handling the data from the products, extract the necessary information, and provide the necessary services both to the customer and the OEM. This example illustrates how the ICP for Life customizer component covers some levels and milestones of the collaborative product service pathway. Interestingly, the ICP for Life platform also includes a planner component, which is clearly relevant for the hyper-connected factories pathway. This should not be a surprise, since the three pathways that we have until now covered are interrelated and can reinforce one another. The following case is from the Symbiosis project, where a tool supplier installs a smart spare tools cabinet on the end user's factory floor. It communicates to the tool manufacturer the consumption of the cutting tools and hence the need for replenishment. With these IoT-based technologies, the already existing maintenance and replenishment services can be significantly optimized. The following case is from the BNCPPS project, another Factories of the Future project. BNCPPS is part of the I4MS scheme that features a lot of SME cases. In the smart mold case, the company Pernod designs high-tech steel molds for plastic injection. The objective is to add intelligence on plastic injection steel molds to transform this mechanical system in a cyber-physical system, with an expectation of improving quality and reducing costs and delays of the part produced. To reach this objective, the mold is instrumented with different embedded devices. These monitoring capabilities produce alerts for the operators to allow them to react to possible malfunctions which could lead to quality problems in the produced pieces. Also, the smart system is linked to a cloud, allowing an access to the entire life cycle of the tool from anywhere at any time. These approaches and the associated services reduce the number of defected parts by optimizing the operator's time to react to deviations. It also reduces the number of maintenance operations. One additional comment related to the previous three project cases. Since the services are associated to production equipment, the cases do also fit in the Smart Autonomous Factories pathway. The Collaborative Product Service Factories pathway focuses, however, on the interactions between the equipment supplier and the equipment user from the service perspective, impacting also heavily the design of the equipment as well as the associated business models. If you wish to promote your experience and cases on the Connected Factories media or the EFRA Innovation portal, then please let us know. You can find us via the Connected Factories website